Okay, so now we're going to talk about passing arguments by value. So, what do you mean? What am I saying? You might ask. Well, now we're gonna take a look at how these arguments get mapped into the parameters in the add function. So here we're calling function add, giving some arguments, and then you have the definition of the function called add. It just adds two numbers, integer numbers x and y. These are the parameters. So what is this mapping relationship like? So what is really being passed? Is it a copy of those numbers or the actual numbers themselves? So that's when we have to think about passing arguments by value and passing by reference. So passing an argument by value means just you're passing a copy of those arguments to those parameters. So whatever you do in your function, you're doing on a copy of the arguments that were passed in, and because of that, when you go back to wherever you call the function, whatever you passed in will remain in their original state before calling the function. Because you just passed on some copies, you did some work using copies, but you never actually changed the original argument. That's called pass by value. Now the other kind of pass is when you actually want to pass the arguments and you actually want to change the original arguments that were passed as parameters to the function. That is, you pass some arguments, the function does something with those arguments that were mapped to the parameters, and you want those changes that took place within the add function or any other function to remain to keep their state even after going back to whatever the function was called. That's called pass by reference. When you actually pass the arguments and you want them to be changed, the original arguments to be actually changed. And what happens in pass by reference is you're actually passing an address, like a pointer. And that's beyond the scope of this video to explain what pointers are, but just in a nutshell, pass by value, you're passing the copies of the values, and thus, because of that, you will not be changing the original arguments. Pass by reference, you are actually passing the arguments to the function, and any changes that take place within the function that was called will remain even after the function is terminated. So there's permanent change, there's destructive behavior. So let's start talking about pass by value with an example. So I want to create this function to add 1 to an integer number. So that's all it's going to do. I want to add 1 to whatever the integer pass. If I pass 1, it's going to add 1 to that argument, and it's going to become 2, and that's it. I don't want the function to return anything at all. So that's one more aspect of functions you're going to learn right now. If you don't want a function to pass to return any kind of thing in particular, just say void. They're called void functions. I'm going to call add 1. My input is just a number to which I want to add 1. I'm going to call it 1. And what I'm going to do is I want to say, okay, my number is equal to number plus 1. I just want to add 1 to that number, and that's it. There's no return here because I have a void function, meaning there's no return value for this function. A void function doesn't have a return value, so we don't want to return anything. All I want to do is I want to take my argument, whatever I call the function, I pass in a number, integer number, and now what I'm going to do in this function is add 1 to that number. Okay, so let's see what happens when I do that. And just as for debug purposes and know what's going on, I'm going to put a cout right here saying changing number parameter to whatever number is. Put a break of line there. Okay, so I'm gonna call it, go back to main here. Let's get rid of all this stuff, comment out. So don't worry about that, just main, so return 0. So what I'm gonna do is I am going to call add1. So it takes an integer. So let me create an integer here. So declare a variable called a, and at the same time define it to be 89. What I'm going to do is I'm going to call the function add1 and pass in a as the argument. Then next I'm going to display the value of a. Now my a in main is whatever a is. So let's walk through this. Declare an integer variable, call it a. Assign a value of 89 to the variable a. Pass the variable a as argument to the add1 function, which in turn will map that to the parameter called number, and that's going to add 1 to number and change it, and then it's going to say change the num parameter to whatever that was changed to, and then go back here, going to see out, and now my a in main is whatever a here is, which we're going to find out what's going to happen to a if it's really going to be changed when we pass it to the add1 function. Here we are illustrating pass by value, which you will come to clearly understand once we execute this and walk and analyze what's going on. Let's compile it and run it. So, okay, here's my output. So what I got was changing my number parameter to 90, and then when in main I said now my a in main is 89. What happened here? So a is 89 in main. I call add1. Number gets mapped to 89, right? Because a is 89. So number equals number plus 1. So number was holding 89, but then I add 1 and becomes 90. Now number here in add1 is 90. See out changing number parameter to whatever the number is, which is 90. And I got it here. And then we terminate the function, no return value, because it's a void function. And I go back here right after the add1 call. I do a cout. Now my a in main is whatever the value of the variable a is. And it gave me 89. Even though we passed a to the add1 and we added 1 there. But still we got 89, which is still the variable we defined, the value we defined in main. So what happened here? What happened was you passed a copy of a to the add1 function. And that copy was 89, was added 1, became 90, but once you exit the add1 function, that copy is gone. You're going back to wherever you were before, and a is still unchanged because you actually passed a copy of a, not the actual a itself, the value of a itself, the variable there. So thus you got 89. So that's passed by value. You pass a copy of the variable. Okay, I'm just gonna put some couts here to illustrate that we are entering add1, so that you can really believe me that that is indeed the case. So when I enter the function, I'm gonna say I'm entering the function. When I'm leaving, I'm gonna say leaving. And line. Compile function. So a is 89, entering add1. So we are in add1. We display that changing number, whatever, do number equals number plus 1. We passed in 89, 89 plus 1, 90, display 90. Changing number parameter to 90, leaving add1, go back to main, cout. Now my a main is whatever a, the variable a in main is holding, which originally was holding 89 and still 89. Okay. Pass by value, arguments get copied and map to the parameters. Original arguments remain unchanged after the function call. Now what if we want to actually change those arguments as we pass them to the add1, and I actually want add1 to actually change my original value? That's called pass by reference. And all we have to do here is add an ampersand to the parameter list here in add1, the parameter type, right next to the type. So let me tell you how to do it. So right now you're doing pass by value, right? You're copying the arguments. Whatever gets passed in as argument to the number parameter gets copied. What if I don't want to get it to get copied? I wanted the actual thing to be passed. So I do this. I add an ampersand right next to the type. So now I'm saying, okay, this is passed by reference. You have to actually give me the actual thing. Don't give me a copy. I want the real thing, and I want to do something with that. I want to add one to the real thing, and when I get back to wherever I was, which is main, I am going to actually see the change to the variable that was passed. Let's try it out. Compile, run. Voila. See that? 90 and 90. So here A is 89. You passed A. But that parameter that is mapped to the argument A is number. And it has been told it's a pass by reference, meaning don't copy the argument, give me the actual thing. So actual A was whatever 89 A was pointing to, get passed, and then we say number equals number plus 1, 89 plus 1, 90. Go back there. A, which was passed, actually changed because it was passed by reference. Now it's 90. And then we say A, and then it's 90. Okay? All this happens because of pointers. You're actually passing a pointer, meaning you're passing an address. So think of the ampersand as an address. Whenever you see 1%, you're passing an address. Okay. Meaning you're passing the location to where that thing is pointing to. Again, this video is not about pointers, but just so you know, that's what is happening. You're actually passing the location, the address, the pointer. There's a location where there's an 89 there, and what you're passing is the how to go there, the address. And whenever you change number here, you're actually number is pointing to that location with the 89. So you're changing number here. You're adding 1, so it's going to add 1 and become 90. So wherever that 89 was, now it's 90. And then when you come back here, since A still points to that location, it's going to be 90. Okay? And this is pretty much it for this video. Just to wrap up the topic, you notice I put everything before main, all the function, declarations, and definition at the same time. So that's because if you try and put them after main, like this, since they were declared after main, and you try to call them in main, it will say, oh, I don't know that function because it wasn't declared before. You can try it out, compile it, see the compiler saying here, error, add1 was not declared in the scope. So because add1 was declared later after main, so it doesn't know it was about that function. So you gotta put it before. But yes, there's a way to do this, actually putting everything down there and letting main know that function exists, is by using it's called a prototype thing. The way you do it is you take these, you put in the bottom. But then if I do that, they don't know about all these functions. So I have to find a way to tell whatever comes after those functions, which is main, originally, and have to tell it that these exist. What I'll do is we'll copy the function header and I put it here, semicolon. Copy the other one, put it here, semicolon. Copy the other header, put it here, semicolon. Okay, and then I try to compile and it works as expected. Okay, so that's how you do it if you want to put everything at the bottom. And even in this case, it could be the exact same header, but you can also omit the parameter name and just say the type. That will work as well. So let's try it out. No complaints. It works as expected. So the prototypes don't even need the parameter name, but you have to have the type, you have to have the return type. That's for sure. So this is pretty much it for this video. Just an introduction to C++ functions. So again, just reiterating, if you have a code that you find yourself writing very often and repeatedly, you should make that into a function. Give it a name and then you can call that function from anywhere and as much as you want, and you only have to write that once, write the code once, run it as many times as you want. Also, functions allow for modularity. You can add new features, new functions, remove them from some kind of system without compromising the whole thing. So they're like modules. So remember, function has input and an output. Input are whatever you pass in as arguments, which get mapped to the parameters of the function. And they're put in the parentheses here. Then the return type, the output, always in the beginning of the header. For functions with no return type, say void. Here's int for our case. So in our case, we just did a function with integer values and returned an int. We simplified it very much, but we could be any type as return and any type as the parameters, and I'll leave that to you to try it out. So as an exercise, you could try to fix that problem we had with the passing a float, and we always got a truncated integer with the kind of wrong answer mathematically. You could change the parameters and the return value to a float or a double and see what happens. Try changing first the first argument to a double and see what happens. Try some tests and then you will see some things going on. You will see that x here will actually be a double and it's being added to an int, but that double, is it gonna be truncated as an int, or is the y, the integer, gonna become a double? So I'll leave that to you to find out. Okay, and also keep in mind what's happening at the output with return value, if it's an int, if it's a double. So change that too. So that's a good exercise and see what happens. Okay, and later we talked about passing by value, passing by reference. Pass by value just means you're passing in copies of the argument. The original arguments will not be changed upon return from the function. When you pass by reference though, the actual arguments can be changed permanently. So when you come back, they might have been changed if your function did something to them, some operation that changed their data integrity. So pass by reference uses an address pointer That's how it actually changes the thing. Alright, thank you for watching this video. Any comments, please post below. Please subscribe if you like my videos. Thank you very much.